Hello and welcome back to another video. In this problem, we're asked to prove this statement using the precise definition of a limit. And we have the limit as x approaches 0 of x squared is equal to 0. So the precise definition of a limit states that if you have the limit as x approaches a of f of x is equal to L, this means that for every positive number that you can think of, which we denote as epsilon, there is an associated delta such that 0 is less than the absolute value of x minus a is less than delta, and the absolute value of f of x minus L is less than epsilon. So what we have to do is we have to plug in our values from this problem in particular into these equations, or inequalities rather, and we'll be able to get a relationship between delta and epsilon that states, okay, give me any epsilon and I can tell you how to find delta. So we have a is the value that the function is, the x variable is approaching. So that's 0. So 0 is less than the absolute value of x minus 0 is less than delta. Therefore, the absolute value of x is less than delta. And we have to take a second to say, okay, the fact that the absolute value of x is greater than 0, what does that mean? Well, that only means that it's not equal to 0, because it's already greater than all the negative numbers by virtue of it being an absolute value. And since we're looking at the limit as x approaches 0, not what's happening at 0, we can ignore this. So the absolute value of x is less than delta. F of x is the function, so that's x squared. L is what the limit is equal to, so that's 0. And this is less than epsilon. So therefore x squared, or the absolute value of x squared, is less than epsilon. And what we can do now is take the square root of both of these sides. The square root of x squared is x, or rather the absolute value of x. Taking the square root, we don't really have to worry about putting that inside or outside of the absolute value because square roots are all positive anyways. This is less than the square root of epsilon. If the absolute value of x is less than delta and it's less than the square root of epsilon, we can say that delta equals the square root of epsilon. So therefore, for any epsilon we choose, if you take the square root of it, you get a delta for which these inequalities are true. And if we reverse this process by plugging back in the square root of epsilon, we can see that it's actually true. So if we square it, we get the square root of x squared is less than delta squared. Plugging in the square root of epsilon here, we have the square root of x squared is less than the square root of epsilon squared. And the absolute value of x squared is less than epsilon. If we subtract 0 from x squared, we can see that f of x minus L is less than epsilon. Therefore, this relationship is true for the limit.